3, 2, 1.
Welcome back. Today we're going to be building a Christmas tree rocket. It's going to go up in the shape of a normal rocket, and then the main body tube will open up like a fairing, and hopefully a Christmas tree will pop out. To start with, we're going to make some supports for the mechanical arms, or in this case, limbs, for the Christmas tree. I'm just going to cut these trapezoid shapes out of some sticks of balsa wood, and they'll serve as the base of the hinge and to spread some of the loading forces for the limb deployment across the body tube. We're going to do 2 rows of 4 each, so we're going to make 8 plus some spares. And then once these are all cut, we're going to cut another stick of balsa wood to serve as a spacer there and a stopper for the arm. We're going to glue those in place and clamp them. Once those have had time to set, we're going to drill a hole just the right size for a bamboo skewer, which we're going to use as our hinge pins. Then what we want to do is make 2 sort of reinforcing collars out of a spare section of body tube here. So we're just going to roughly measure that, cut it, and then we're going to cut it down the side so that we'll be able to glue the pieces on off of the main rocket and then slip that collar on later. We're also hoping that doubling up the body tube for this section will add some reinforcement. You'll see us here just tacking those in place with some super glue. We did go back with wood glue and a syringe and add several passes to add the fillets and support. We didn't round the base of these hinges, so there was lots of voids that we were able to fill with the wood glue and get a good purchase there. Next, we roughly cut several hinge pins from the bamboo skewer. We leave them long here. Initially, we thought we might need them for attaching elastics. We go back and trim them later because we went a different direction with that. But here you can see how it assembles with the base of the hinge. We're using a different bamboo skewer for the arms themselves. And there's a top-down view of that mechanical action. What we don't see on camera here was we did have to round the edges of those arm skewers just to make sure they didn't sort of mechanically cam into the body tube and kink it. And given that we just roughly hand-drilled these, they ended up sort of being mated pairs where they were sanded and tuned for each other. With each of these reinforcement collars built out here, we're going to go ahead and attach it to the main body of the rocket. We're going to hold it in place with some rubber bands here. And we do want to make sure that the bottom ones are sort of out of phase with the top ones so that they'll lay as flat as possible so those arms fit as neatly as possible. For the festive part of the rocket here, we've taken U shapes of these tinsels with the bend of that going on the top of the rocket and then each side going down to the end of one of these limbs. The hope here also is that connecting it to the end of the limb will help shift some of the mass of this up to the front of the rocket and help stability. You can also see some of the non-spring loaded articulation that we have with these limbs. Next, we're going to attach a centering ring that we put holes through to anchor in the elastics. We're going to do a quick test of that and see how the spring loaded action, if you will, works to make sure that we have enough length. And with that test looking good, we're going to go ahead and put some fillets of glue around that centering ring and cut out the parts for the fin can. Now we're going to make a relatively standard through-wall fin can. One thing that we did want to do, just to not use an internal coupler and have a whole body tube length for the Christmas tree part, is cut these fins long so that we can use those as sort of an external tube coupler. And we'll show how that works out here in a little bit. The rationale for not using an internal coupler was just to make sure that we had room to put larger and more exotic motors in if we wanted to. With the motor mount tube cut to size, we're going to go ahead and dry fit our parts and see how we like the overall lay. And with that checking out, we're going to go ahead and glue them in place here. The next thing that we're going to do is glue the motor retainer on, which you can use super glue to glue that to the end of the tube here. And then with all of that in place, we're going to move on to our favorite part, the fillets of glue. Doing it all with a montage, a glue fillet montage. With the internal portion of the fin can set, we're going to glue that to the rest of the Christmas tree rocket here. And then, of course, that gives us the opportunity to do another montage of glue fillets. One of the concerns with this external coupler here was that we wouldn't get a solid seal and we might lose ejection gases or have it fail at that point. So we trimmed some body tube section down and come back in and reinforce and glue those out there just to give it a little more strength and hopefully seal it off. To finish off the fin can, we're going to cut this. This is a Lock high power 2.56-inch tube, so it's going to take a little more effort to get through here. And then we're going to mark for the fin placement. We'll take our straight edge and mark those down and give just enough of a gap between the lines, hopefully, for the fins to fit. We'll check the length where we need to stop those cuts and mark that. And then we'll cut out the slots for the fins. Once we have that, we'll come back and do a dry fit. And then we'll take the file and adjust these slots just a little bit so there's no bowing on the airframe there. And once we're happy with that, we'll go ahead and glue it in place. Of course, we're going for a tree stand appearance on the bottom portion of this rocket. Hopefully that's obvious here. And from this angle too, you can see where we've rigged the elastic cords to pull the tree limbs down. Then we're just going to clamp that in place and let it set. And then when that's done, we're going to follow up some more fillets of glue. What we need to add to the fin can here is a little retaining ring to help hold the bottom pieces of the fairing in place. So we're going to cut another little piece of body tube here and then cut it down lengthwise and mark the fin placements here. Then we're going to go ahead and notch for those fins and install that ring on the top of the fin can here. And then we're going to come back with a syringe of wood glue just to lock it all in place. Once that's done, we're going to move on to making the fairing portion. So we're going to cut down to size another high power lock tube. Then we're going to take our piece of paper here and fold it over to figure out how to bisect this cylinder and mark that, and then run those lines parallel to the length of the body tube. It is worth noting that I modeled this just as a solid cylinder. That was probably not the right thing to do. There are some gaps left. By the time we're done retaining it, I think there's probably a little more drag and a higher effective diameter there. Our first attempt to retain the top of it was to do this weighted nose cone with just a really thin single retaining wall up top. The friction that this provided to the front ended up being too much. We tried to do a blow test to see if it would eject nice and smoothly with the actual fairing packed. And it did not. So we kind of tried to cut that down, tried a few different shapes, tried just breaking it off. It proved really brittle anyway. Here you can see the blow test failing. So that didn't work. The next thing that we're going to try was to add these supports to take some bamboo skewers and hold those in position, hoping that would give less surface area but still have some strength and avoid the brittleness. The issue with this is once it was packed, it didn't hold the front in far enough, so there was forward-facing holes in the airframe, and I didn't think that would help the stability or not just rip the fairings right open. So we're going to try it. It didn't end up working out. So then what we're going to do is cut some sections of body tube here and glue those between them to hopefully have a less brittle ledge, a slightly wider diameter than what we failed with the first nose cone print. So just going to tack that in place with some super glue here and come back and glue it in a little bit further. We tried it with both the skewers and the body tube. The skewers broke right away on impact, and once the body tube was there, it didn't really add anything to the overall situation. So we abandoned that, and here you can see we just sort of scalloped the edges of that body tube just to reduce the surface area for friction. Next, we're going to install the rail buttons here, one at the centering ring on the top of the fin can, and another one on the top of the fairing. There was a little bit of bowing possible on the fairing, so we wanted to not put it all the way on the top, just to make sure we had standoff from the rail. And of course, in hindsight, this should have been another indicator that perhaps our straight cylinder simulation model wasn't the way to go either. You can also see on the underside there, we took a thin CA glue and wicked it into the cardboard to reinforce and strengthen those edges on the tops and the sides. For the recovery system, we wanted to fit a large parachute in this narrow diameter body tube. So I wanted a flush mounting shock cord So we drilled a hole through the second sort of reinforcement collar there, holding the limbs, and fed the shock cord through there, and then tied and wood glued it to the outside of that main body tube. Once that was done, we actually took another piece of body tube and glued it on over the hole where we made, just to make sure that we were sort of sealed off for ejection gases and everything was nice and in place. Then we'll measure off a few rocket lengths of shock cord here. We were hoping the parachute would be out of the way and not interfere with the dramatic effect of the Christmas tree dropping down. The goal was to retain the fairings with a piece of Kevlar string so that they would peel down, float, and lay under the Christmas tree as it descended. So to do that, we needed to anchor them in. We wanted to anchor them in on the top so that the whole thing would sort of invert and give us a longer distance on the bottom, but not have to introduce any more complications in the rigging. So what we did is we just took another little piece of skewer here, cut that, tied it into a knot, and then wood glued the whole thing in place. The side with the rail button, we did this on one of the corners. The other side, we did it in the middle. And again, here the goal was to sort of spread that force over a reasonable distance so that it would not kink the tube when deployed. With the top of the fairing secured, we moved to anchoring the bottom portion. So we just drilled holes through the fins so that we could tie that Kevlar string in place there. And then use a adjustable knot to set the tension on the string. The next thing that we're going to do is go ahead and anchor the attachment point for the nose cone. Now, one thing we do see here with the nose cone is we didn't do any stress relief or any filleting on that joint from the small body tube to the larger frame, and I think that'll prove to be a problem. But pressing on for now, we're going to go ahead and attach a swivel to the parachute lines and then tie that to a midline knot there on the shock cord, and then tie the shock cord to the nose cone. We're going to add just a little drop of wood glue just to keep that Kevlar string from untying itself. And here we are doing a balance test with a piece of Kevlar string just so we can go in and update our simulation with the S-built. You can also see the simulated center of pressure there marked as well. And as we rotate it, you can see there is a little bit of a gap and just some of the tinsel sticking out, even though we did get a little more tightly packed before flight. We are planning on doing an after-action review for this as well, so tune back in for that.
3, 2, 1. Whoa! Look out! Three, two, one.
From our lab to yours, have a Merry Christmas.
Thanks for watching. Ho, 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 ho.